Hi everyone, welcome to the channel. We're going to be solving question 67 from the second chapter of the Hibbeler textbook, and we need to determine the magnitude and coordinate direction angles of F3. And we know that the resultant of these three forces, F1, F2, and F3, is along positive y-axis, so we can show the resultant with FR, and this will be our FR along the y-axis, so that means we don't have any x and z component for FR. And we also know that the magnitude of the FR is 600 Newton. So if we want to show FR in a vector format, as I mentioned, we don't have any X and Z component. And since it's along the positive Y-axis, we have 600, which is the magnitude. And so our FR is basically 600J, which is in Y direction. So what we're going to do in here, if we can find the sum of all forces in X direction, we know that this has to be equal to 0 because that's going to give us the X component of our FR. So we can go with X component of each of these three forces. And at the end, we'll end up with one equation from sum of all forces equals X. So let's go with that. If we look at F1, we see that F1 only has X component and it's along negative x-axis, so we have minus 80. That's everything for F1. If we look at F2, we have to find the x component of F2, and this might be a little bit tricky to see what's going on in the figure, but I'm just going to show it in 2D. Maybe we can see and understand it better. So if we look at from the point of view of this guy, we're going to see the origin here. We have our x-axis, and this will be our z-axis. And the force F2 that we have is this force in here, F2. From the question, we know that the projection of F2 on xy plane is this line in here, which would be what we have in here. And the angle that it makes with F2 is 30 degrees, which is this angle. So I'm going to show it in different color, then we can use it later too. So what we have in here, I'm going to show it in green, is what is in here. And if you want to find that, we basically have F2 times cosine of 30 degrees. And once we have that, we can break it down to x and y component pretty easy. So if we want to find the x component, we basically have what we have in here, which if we look at here, it can be also this force too. So it will be, since this is a right angle, we have a right triangle, which I'm going to highlight it in yellow. We have this yellow right triangle. So this side would be the hypotenuse, which is F2 cosine of 30 degrees. We know F2 is also 300. So if we want to find the opposite side, it will be F2 cosine of 30 times sine of 40 degrees. And the y component would be what we have in here. It will be F2 cosine of 30 degrees times cosine of 40 degrees. So now that we have that, so as I said, the x component would be F2, which is 300 cosine of 30 degrees times sine of 40 degrees. So that's the x component, and it acts along positive x-axis, so it is positive, and we have F3. So if we get back to the question, we see that we are asked to find the magnitude and coordinate direction angles. For that, what we need is the unit vector of the F3, and if we want to figure that out, we know that unit vector of F3 is basically cosine of theta x plus cosine of theta y plus cosine of theta z. Okay, and that's one way of showing the unit vector. we need to memorize this formula. In the previous video, I showed where this is coming from. It's basically from the definition of the unit vector. And what the question is asking, first of all, is the magnitude, and second of all is the coordinate direction angles, which are theta x, theta y, and theta z, which are basically the angle of F3 with positive x, y, z axis. So basically in this question, we also need the magnitude of F3. We have 4 unknowns, meaning we need 4 equation in order to find all the 4 unknowns. So if we want to find the x component of F3, we basically have F3 times cosine of theta x, which is one of the unknowns that we have. We have same thing for Fy, but this time Fy is not 0, it's 600. So we have to go to y components of F1, F2, and F3. So F1 is along the x-axis, so there is no y component from F1, 0. We showed that the y component of F2 is plus 300 cosine of 30 degrees, cosine of 40 degrees, what we have in here. And for F3, as we can see, we have plus F3 cosine of theta y, which is the other unknown that we have. Let's move on to the third equation. This will be also equal to 0. F1 doesn't have any z component. We have to find the z component of F2, which is what we have in here. So this would be F2 sine of 30 degrees. And since it's downward and in the opposite direction of z, we have minus. And we know F2 is 300 sine of 30 degrees. And we have plus F3 cosine of theta z. So far we have 3 equations, and another formula that we also covered in the previous video was that we know that the magnitude of the unit vector is 1. And for finding the magnitude, we basically have, let's just write it down in here. So we know the magnitude of unit vector is 1, which for any vector, we basically have the x component plus cosine squared of theta y plus cosine squared of theta z. We're just gonna take the power of 2 on each side, and we'll get to this formula: cosine squared of theta x plus cosine squared of theta y plus cosine squared of theta z is equal to 1, and that would be our fourth equation in order to find the 4 unknowns that we have in here. So this is the first, this is the second, and this is the third. And from this one, we can find the 4 unknowns that we have in here. The rest of this is solving these equations. And for solving this, all we need to do in here is to find cosine of theta x, cosine of theta y, and cosine of theta z based on F3, which from each equation we can do that. And once we put it in here, we can find F3, and after that, with F3, we can find each angle. And if we do that, what we're going to get as the final answer is that our F3 would be 428 pounds. What we get for theta x is 88.3 degrees, and for theta y, we're going to get 20.6 degrees. And the last one, theta z, would be 69.5 degrees. And that's pretty much everything. Or let me know if you guys have any problem finding each of these. So as I said, like from the first one, for example, we can find cosine of theta x is equal to 1 over f3 is equal to 180 minus 300 cosine of 30 degrees times sine of 40 degrees. And we can calculate the value of this. And we're going to do the same thing for the other two. And after that, we have the value of cosine of theta x, cosine of theta y, and cosine of theta z. And if we put it in here, we can find F3, which will get to 428 pounds. And after that, if we put F3 in each of these three equations, we only end up with one unknown, which you just have to do the cosine inverse of that value, which it gives you theta x, theta y, and theta z. And we should be good to find the coordinate direction angles. Hope everything was clear, and you guys take care. I'll see you in the next one.